No, it wasn't.
Yeah, it was until the last one.
Yeah,
Yeah, the
that.
last stuff.
I know, it's hard to follow directions.
Yeah, it is.
Wow.
So,
Breaking
What is
stuff.
that? So the last chapter was chapter 7.
so this is chapter 8.
Okay, so today's lesson is fairly simple when it comes to graphing.
Did you go a little slow?
I'm waiting at this moment, and you're talking, you should be writing. That's why I'm standing here talking, so that you can write it down. You're still talking. So the first section today is really the basics of graphing, making an XY chart, substituting numbers into an equation, and trying to plot points on a graph. Okay, so the rate of change is really the same thing as slope. You guys remember slope? Slope of a line, change of your y coordinates over the change in your x coordinates. And that's what we have up here. A ratio is the fraction, so slope, or rate of change, is a fraction. The change in the y coordinates, the second y coordinate minus the first y coordinate, the second x coordinate minus the first x coordinate. So you got to pick two coordinates, subtract the y's over the subtraction of the x's. The typical mistake students make is they put the x's on top and the y's on the bottom. So I've warned you, don't do that. You miss the whole problem if you do. Okay? So this is the change in the y coordinates over the change in the x coordinates. Rise over run. And I'll talk about that stuff as we go. Yes?
Do you have figures?
No, I don't. I have it. Well, I have it in that piston back there. The desk is a smaller one. No. All right, so we've got quite a few examples to go over. Example 1. I'm going to graph each of these. Y equals x minus 2. We did go over this before the last acuity test, but this chapter we're going to spend a little more time being a little more critical of each one. Okay? So the first thing you should always do if you're asked to graph something and you've forgotten any shortcuts that you were taught is resort to doing an XY chart, where you plug in some values. Alright, so we're going to plug in some basics, some negative values. We're going to plug in the 0, see what happens when x is 0, and then some positive values. And you only need 2 points to graph a straight line. But we're going to go ahead and graph these 5 points just to show that it works and to show what happens in the negatives and the positives. Yes?
You can have any points to know that x.
Yeah, you can use any points. Okay, these are just the typical ones we choose. All right, so plug these in. When x is -2, we substitute, just like what you got done doing in substitution in the last chapter. X is -2. What do you get for y? -2 minus 2 is -4. -1 minus 2 is -3. 0 minus 2 is. Notice that this -2 is the same as that number. That is called the y-intercept, which we're going to get into in the next couple sections. Alright, so when x is 0, you're going to have this exact same number for your y-intercept. When x is 1, what do you get? And x is 2?
0.
Alright, so now we graph those. And you can make an xy graph plane and on your paper. And just try to be as accurate as you can. You can use graph paper if you want. So -2, -4, that's a coordinate. So that's what you were finding, coordinates. So -2 on the x-axis, and then -4 on the y-axis. Put those two together, and that's your point. You don't need to draw those dotted lines. I'm just showing you that's how you do graphing. Okay? And Anybody struggling with how to graph coordinates? Okay, everybody graph the rest of those. Accurately as you can, and then draw a nice straight line. These are linear equations. And you need to be very accurate. So the reason we graph more than 2 points, you only need 2 points to make a straight line, but the reason we graph more than 2 points is just in case you made a mistake. -1, -3 is right here. 0, -2 is your y-intercept. 1, -1, and 2, 0. And that is the graph of your line. Now just to go back over what we talked about before, the rate of change or slope is really in this position right here, the coefficient on the x, when y is by itself. So what is the number on the x?
1.
1. So notice what the ratio is here. I'm just going to show it to you on this problem. If we take these first two coordinates, we'll say this is x1, this is y1, we'll call this an x2, and this is y sub 2. And let's use this formula. So y sub 2 is -3. The formula says we subtract. Y sub 1 is -4. That's the top part of my ratio. The bottom part is x sub 2, so that's -1. We're supposed to subtract. X sub 1 is -2. And what's minus a negative?
Positive.
Plus a positive. Okay? So what do we have? -3 plus 4.
7. Nope.
1. -1 plus 2. What is that?
1 whole.
What's the number in front of x?
No 1.
Okay. That is your rate of change. The number in front, the coefficient on the x, when y is by itself and positive.
So, if they
So this tells you your rate of change,
okay, so when they after $1,
if there's a 1 in there.
well, yeah, like,
Okay. All right, example 2, let's take a look at this. Y equals x squared. This is not a linear equation. Linear equations has a high exponent of 1. Everybody look. The highest exponent is a 1. This is a parabolic equation, it has a 2. So it'll show up a little differently when we graph it. So again, I want everybody to put these values in and figure it out. Yes?
How did you get the 3, 4, 1, 2 thing? What is that?
The fraction,
Yeah.
I use this formula here to find slope or rate of change. I picked two coordinates. I could have picked any of these two coordinates and I would have gotten the same answer. Okay? I just chose the first two. So this is my first x coordinate, my first y coordinate, my second x coordinate, my second y coordinate. So that's what those subscripts are. Okay? And we're going to go over this in the next section, I think.
What is the little 2 and the 1 thing?
That's which coordinate you chose. This is the first coordinate, so these are the ones, x sub 1, y sub 1. This is my first coordinate I chose. This 2 means this is the second coordinate I chose. That's why I wrote these above them like that. Okay? Understand? All right. Everybody done with this? Did you graph it?
oh,
If I square -2, what do I get?
4.
Positive 4. If I square -1,
1.
square 0.
0.
If I square 1,
1.
I square 2.
4.
All right. So this is what it looks like. When x is -2, y is 4. When x is -1, Notice it's not a straight line. This is what we call a parabola. And this is curved at the bottom. Make sure you curve it. Do not make it a V. It is a U shape.
I have not get that.
Because you can go up. That's positive 4. It's up here.
Dang it.
Mr. Love,
Yeah.
how come like here, like, only managing
Because you didn't use parentheses. The question is this. How come when you put in your calculator -2 and then you square it like that, it gives you -4?
They use parentheses.
Because you didn't use parentheses. This is -2 that you substitute for x. What did I say you're supposed to do when you substitute? Put parentheses around it. Because this 2 means I'm multiplying the parentheses times itself. -2 times -2. This is saying that 2 is being squared, and there's a -1 for a coefficient on that. There's a -1 here, but it's inside the parentheses. -1 times 2 is -2, and I still got to square it. So that's why it's a -4. It all depends on where your negative is, if your exponent's even or odd. We've talked about this all year. That's why some of you guys miss your questions on some of the tests. If it's not in parentheses, then it's not attached. Okay? Alright, example 3. Y equals 2x plus 4. Right now, where's across the y-axis?
What?
What's the y-intercept?
4.
Good. What's the rate of change?
2.
2x.
Slope, 2. Alright, so everybody do an XY chart, plug in all these points, and graph it. It is a linear equation because the highest exponent is 1. So it's going to be a straight line. Everybody graph this. Copy not good enough for you? Yep. No. 2 times -2. Oh, are you saying is your answer after you add the 4 0? Yes, that's correct. I thought you meant 2 times 2 is 0. That's what I thought you were saying. 2 times -2 is
0. What's 4?
2 times -2 plus -2 is 0.
Oh, I'm doing
2 times -2 is what?
-4.
-4 plus 4 is 0.
Okay, I see.
Oh, I forgot that part. Distractor.
Look. Is your XY chart correct? Okay, here's what I want you to see. Where's across the y-axis? What's the y-intercept?
4.
Because when, at this coordinate, x is 0, isn't it? At that coordinate? Anywhere on the y-axis, what's the x coordinate? 0. So when you plug 0 in, this goes away, leaving just that number. That's why we call that number the y-intercept. Not just because, hey, let's just pick a spot and call that the y-intercept. No. It's mathematically proven that if this is 0, then y equals 4. Okay, so I know it's going to cross the y-axis at that number. I know that this is 2. What's 2 as a ratio, as a fraction? 2 over 1. Now look, from one point to another, if I rise 1, 2, and I run 1, I get to that point. Rise over run. We're going to talk about this again in the next couple sections, but I'm just kind of putting it out there for you that will get you from one point to another. Okay? But today you're doing XY charts. Example 4. Y equals 2. Can you make an XY chart?
Oh, wait.
Watch. Here's your XY chart. So everybody copy it all down. And again, you don't have to pick these values. I'm just picking those just because it gives me a nice round grouping of numbers.
No.
Okay, I want everybody to watch. When x is negative 2, y equals 2. When x is negative 1, y equals 2. When x is 0, y equals 2.
I don't understand.
Y equals 2
Either way, yeah.
for any value of x.
Oh, God, it's
So how do I graph that? Everybody graph it. Everybody graph it. It'll be a what, Hannah? Graph it. Everybody graph that line. It's a special line.
Wait.
Yeah, it's a straight line. It's still linear.
How do you do that again?
When x is, when you just have a variable by itself, like y equals 2, or y equals negative 1, or y equals 0, there's no x in it. Then no matter what value you have for x, it's just, the y value is what it says.
Oh.
Okay? So if you graph that, you get what? A horizontal line going through what axis?
Y.
So this is to help you remember if it's horizontal or vertical, because the next example is x equals negative 3. What do you think that is going to be?
You plug all those variables that we do into x onto the y side, and then all those equals to x.
Yeah, x is always going to be negative 3 no matter what value you have for y. That means this, if we graph it. I know it's cold. X is negative 3 no matter what value you choose for y. Okay? So it is a vertical line going through what axis?
X.
Okay, horizontal line is not going to go through the x-axis. It may be on the x-axis, meaning what's y if it's the x-axis?
0.
Yeah, y equals that. The equation of the x-axis is y equals 0. The equation of the y-axis is what? X equals 0. These are special equations that you are to never forget. Not y equals 2, y equals whatever, and x equals whatever. Yes?
So you really don't have to use your explanation?
No. No. So if I say x equals 5, what are you going to draw for me?
A graph.
What are you going to draw? Any vertical line?
No.
Goes through the 5 on the x-axis. Okay. All right, so don't ever forget this. All right. Example 6, last one. Given a table of values, I want you to tell me what the rate of change is. Those numbers look familiar?
Possibly, yeah.
Like the rate of change is that little thingy that you did right there, right? The little equation.
Yep.
Okay.
So these are coordinates. It's just written horizontally instead of vertically.
Move your head.
Yeah. Go ahead.
Move your head. No.
So what are you going to do to find the rate of change?
Take. Do that thing.
This right here. You're going to take two coordinates, subtract the y values, and subtract x's. Here's how you do it. Instead of writing it out like I did over there, what is my y? What's the difference in these two y values? -5 minus -2. What do you get when you do that?
3.
-3. Now, that's the top part of the ratio, the subtraction of the y values. What's the bottom part? Subtraction of the same x values. So what is -2 minus -1?
You did that one.
-2 minus -1?
No, because you said we have to put the second y first and then the first y second.
Okay, now the importance of that is this. It doesn't matter which one you put first, as long as you keep it the same on the x values. Meaning this, watch. So what is the y value change over the change in the x value? What is that? -3 over -1, which is
-2.
negative over negative is positive, 3 over 1 is 3. Okay, now wait. So I want to address what you're saying. If I go left to right here, I better go left to right up here. That's what those numbers mean. It means go the same direction.
Oh.
So if I would have gone -1 minus a -2, what would my answer be there? It'd be +1. Now what's -3 over +1? -3. Are they the same? No. The point of those subscripts is the same. Make sure you go the same direction. Okay. So now wait, you're not done. You have to verify that it's the same for all of them. So what's -2 minus 1? -3. What is -1 minus 0? -1. What is -3 over -1? All right. 1 minus 4. 3. 0 minus 1. 1. -3 over -1 is 3. 4 minus 7. -3. 1 minus 2. There you go.
Well, what if they end up different?
You did it. What you're going to be finding is the rate of change that's a constant. They should be the same.
Oh.
But you have to verify it. If you get something that's different, then you might want to recheck your math. Yes?
So that's going to be one of the problems.
Something like that. You have to do something like that. Anna,
How did you get positive 3 out of that?
negative divided by a negative.
Divided.
Well, yeah, watch. A -3 divided by a -1. What times -1? Think about it. What times -1 gives me -3? +3. All right, your assignment. Page 341. 1 to 27 all.
Hey, how